subject is out of the discussed problem, but nevertheless, I think some information will be useful for you. First of all, technical requirements for validation. Technical requirements are developed by commercial companies, and it is restricted information to some extent. Thereby, some positions are empty. Nevertheless, I present you some true data which shows that technical requirements now are quite severe. For example, one count CD drag is not subject of interest now. Half counts is a new requirement. The other parameters must be presented so very accurately. It's a typical picture for CFD community when people try to compare CFD data in the frame of different kind workshops. And you see that the range of CFD data is comparable with the scale of the phenomena on the study. It's typical, but it's necessary to pass through this problem. The dispersion is also typical for wind tunnel test results. I found data for well-known common research model, CRM, and these data are from very respectable test rigs. It's National Transonic Facility, NASA 12x12 wind tunnel, and also European Transonic. Easy to see that range or dispersion is quite severe, and what's to do? Let's make the next step. It's not a secret that wind tunnel walls and wind tunnel mountings impact result essentially. The main parameters, Mach number and alpha, are measured in so-called control point. Model influences this parameter essentially. Usually we say about blockage and upwash phenomena. You can see real data from real test campaign. For example, when you speak about 0.85 and incidence 3, in fact you have 0.847 and incidence 2.62. That is out of range. So when you see in the journal or in the open parameters value 0.5, for example 3, it's necessary to think about what kind of data do you have, in fact, original or corrected. Model can't be attached to air. It is mounted on sting and also sector. There are very, very massive devices, and these devices influence the wind tunnel result essentially. This picture permits you to compare the size of the model and the size of the sting and support. It's not a secret that sting and support create additional blockage, and this blockage moves shocks forward essentially. As a result, this influence gives you mistake or correlation which is equal to 17 drag counts. It's a real figure. Remember about the 0.5 drag count requirement. The second problem is cavern between the sting and the model. It's bad luck if you'll try to avoid this cavern. In this case, due to deformation, model will touch the sting and strain gauge stop working immediately. So cavern exists. To study this phenomena, it was designed in ETW special model, which permit to vary the shape and the area of cavern with the permanent incidence angle. This model and also generalization of the experimental data gave us an estimation that influence of cavern is also quite essential. It may be up to the 7 drag count. It also influences lift, of course. Cavern is not subject only for the sting. You can see the model which was used for Saristo during European project. The model was with cavern between the model and peniche, and it created essential deviation which did not permit to agree or to harmonize CFD data, thanks to Alexander Lysenkov, who supported this CFD campaign, and experimental data. You see that mistakes not only in values but in derivatives also. Stall. The linear part of the polar is very interesting, but the now new requirements, so short distance takeoff and community noise requirements, created the new need to investigate the stall and, of course, buffet. Experimental data for stall are strongly depend upon the wind tunnel quality. Here I can present you the data obtained in 2 TsAGI quite big wind tunnels. The model was similar. It had the permanent ratio of span to wind tunnel size. Also, Reynolds number per meters was also the same. The only difference is the real Reynolds number, 15 million in this case. And you see that stall obtained in the frame of the campaign using the cheap small size wind tunnel was absolutely wrong. It's not a secret that wind tunnel walls also influence these parameters, and these parameters can't be correct. It's not a blockage. This absolutely uncorrectable value. It's ETW. We took part in this campaign, and you see that open-close slots created difference in alpha maximum approximately 2 degrees in incidence. It was the reason of severe misunderstanding of CFD community, which used this data in the frame of high lift workshop. Usual data, they used experimental data as for the free flight model. But in fact, experimental data were supplied with influence of wind tunnel walls. It is the typical dispersion. And you see, it's a typical result for workshop. It's possible to open the handbook and find it. It was funny that many teams tried to explain and to remove this discrepancy by means of the tuning turbulent model and adjusted grid. The second problem of misunderstanding is the common used by CFD community of steady state procedures. In the vicinity of stall, it's absolutely unacceptable. You can see that steady state gives quite a big mistake. But what's to do with unsteady or so-called urans. We discussed this problem quite carefully, and as a result we formulated and documented so-called FOI procedure. It's official procedure now. When you run with urans, it's necessary to organize at least 3 different time-dependent procedures, and in the case of the agreement of these 3 results, including spectrum, maximum, minimum positions, it's possible to say that you have a real uran solution. Otherwise, you just study the behavior of so-called residual non-physical behavior during the stabilization procedure. It's not a secret that the model is not rigid. When you try to calculate polar, it's necessary to take into account that every incidence position you have another geometry. More theoretical structural model is absolutely incorrect, because model has cavities, has so-called tubes, has different conjunctions, bolts, and more. Usual model is not symmetrical. For example, the left wing may be prepared with pressure taps, but the right one, for example, with thermocouples. Therefore, it's absolutely necessary step to organize so-called pre-campaign wind tunnel occupation, when the model is loaded without flow, without flux, but it's on the sting and on the support, and this campaign permits you to create real coefficients for the structural model. In this case, it's possible to calculate real deformation. It's also official procedure now. More, sometimes it's necessary to think about non-linear effect. For example, ETW is absolutely unique wind tunnel, and it's possible to organize study using so-called structural similarity, when dynamic pressure to jungle model is constant. In this case, in fact, we are waiting for that model will be deformed the same way when you vary the dynamic pressure. It is not so, because you can see that so-called twist and bend are absolutely different. What is the reason? The reason is physical phenomena. When you goes up Reynolds number, you see the event or the phenomena when the shock wave goes to the trailing edge. You can see this movement. Thanks to Alexander, who calculated this procedure when we calibrated our program. But when shock moved, it created another distribution of loads, and as a result, another deformation. It's not a small phenomenon, it's quite essential phenomenon which is necessary to take into account. Range. But what's to do? We discussed this problem with different companies, and under the umbrella of Cassidian, we formulated so-called Cassidian procedure. It's necessary to speak about the range. In scientific cases, scientific range can be quite wide, because it must not satisfy industrial requirements. But in industrial case, it should be quite narrow range, and when you calibrate your model, you are okay when your result is inside of range. no emotion, no good results, no excellent results, no only inside or out of range. It's necessary to follow this procedure. So, here's an example of the technical work when we calibrated TsAGI official code for industrial implementation. And you can see that only one point was out of range. And in this case, there are two ways possible. The first one is to agree with the customer from industry this deviation, or to adjust or tune. Usually it's possible to organize local tuning for the grid or for the local tuning of turbulent model. Of course, it's only calibration stage when you become to work to optimize geometry or to create any industrial calculation in the frame of the calibration. Any tuning is strictly forbidden. It's example of our job for CRM. It was the range proposed for the scientific community who would like to use CRM for the scientific purposes. Thank you. That's all. I think it will be useful for you.